Your government's own research lab proved sand stores enough heat to warm a home for days. Building codes make it illegal to use. Finland built one anyway. 8 megawatt hours. Commercially operational since 2022. A new furnace costs $12,000 to $25,000. Then the monthly fuel bills start. They never stop. The system you're about to see costs $300 and burns nothing during operation. The heating industry moves billions annually. This technology has no marketing budget. By the end of this video, you will know exactly how to build a sand-based thermal battery. You'll understand the thermodynamics behind why it works, and you'll see the specific codes that keep it out of American homes. To understand why this was taken from you, you need to see where it came from. Let's start 700 years ago. In a Russian winter that would kill you in hours without heat, the Russian pechka, massive masonry stove, families slept on top of it. A single wood firing heated the home for 12 to 24 hours. This wasn't a fireplace. This was a thermal battery. The principle was simple. Heat a large mass during energy availability. Let it discharge slowly when heating stops. Stone and brick absorbed thermal energy during combustion, then radiated it back for an entire day. Swedish engineers developed the same solution independently, the kakelugn, tall ceramic tile stove with labyrinthine internal flues. Every twist of the flue path transferred more heat into the ceramic mass. Less heat escaped up the chimney. More stayed in the home. Both systems did the same thing. They stored thermal energy in solid mass. Dense material heated slowly. Dense material cooled slowly. Physics, not fuel, determined the discharge rate. Northern Europe and Russia survived on this principle for centuries. These weren't primitive experiments. These were refined engineering solutions that kept populations alive through winters that reached negative 40 degrees Celsius. Now here's what matters. Sand does everything those masonry stoves did, but better. Sand is cheaper than brick or ceramic tile. Sand is more abundant than cut stone. Sand heats to higher temperatures without cracking. Sand is chemically inert. Sand doesn't degrade over thermal cycles. The pechka was a thermal battery built from what was available. Sand is the same principle, refined. So this worked for centuries. What happened? Before we go further, well, you need to know what this channel does. We find practical knowledge that institutional incentives bury. We don't traffic in panic. We traffic in evidence. Every claim in this video is sourced. Every number is documented. If you value that approach, subscribe now. This community values proof over entertainment. Stay here because everything you need is in this video. But there's a deeper archive. The vault. Engineering calculations, regional code lookup tools, supplier lists, thermal storage systems, grid down heating, code navigation guides. We don't pad it. Every page is something you can build or use. Links in the description. Now let's talk about what modern science says about sand. Sand's specific heat capacity is 830 joules per kilogram Kelvin. Water's specific heat capacity is 4,186 joules per kilogram Kelvin. Water wins that comparison. But here's the decisive advantage. Sand heats to 500 degrees Celsius and beyond without phase change. No pressurization required, no degradation, no containment complexity. Water becomes steam at 100 degrees Celsius. Steam requires pressure vessels. Steam requires safety valves. Steam requires engineering overhead that sand does not. The National Renewable Energy Laboratory researched particulate media thermal storage, NREL. Your tax dollars funded this. They confirmed sand as viable thermal storage for concentrated solar power plants and industrial heat applications. The research exists, it's published, it's peer-reviewed. Finland didn't wait for American permission. Polar Night Energy built a commercial sand battery in Kankaanpää, 8 megawatt hour capacity. Sand heated to 500 to 600 degrees Celsius, feeding a district heating network, operational since 2022. That's not a prototype. That's not a lab experiment. That's a functioning industrial system delivering heat to real buildings right now. So let me state this plainly. The United States government funded the research proving sand thermal storage works. A different branch of the same government administers building codes that prevent homeowners from using it. NREL validates the science. The International Building Code and National Fire Protection Association regulations prohibit the application. That's not an accident. That's a choice. So the science is settled. Let's talk about the money. New furnace installation, $12,000 to $25,000 before you pay for a single therm of gas or kilowatt hour of electricity. Then the monthly bills start: gas bill, electric bill, propane delivery, fuel oil truck. The bill arrives every month for as long as you heat that home. That's not a product. That's a subscription. You're not buying heat. You're renting it forever. The sand battery costs approximately $300 in materials: sand, steel drum, insulation, heating element, zero fuel cost if you charge it with solar thermal or waste heat, negligible cost if you charge it with off-peak electricity. Let's be structural about this. Utility-based heating creates recurring revenue. Every home on the gas grid is a monthly payment. Every home on the electric heating plan is a monthly payment. A homeowner with a thermal battery is a homeowner not paying that bill. The industry has no incentive to publicize this. None. Sand cannot be patented. It's silicon dioxide. It exists in nature. A steel drum cannot be trademarked. Insulation is a commodity. There is no recurring subscription to a pile of heated sand. There is no service contract. There is no proprietary component. The business model doesn't work, so the technology doesn't get marketed. Here's what that looks like in practice. NREL publishes research validating sand thermal storage. No major HVAC manufacturer announces a residential sand battery. No utility company offers it as an alternative to gas service. No home improvement retailer stocks the components as a kit. The research gets published, then it gets ignored. Not because it doesn't work, because it works too well for the wrong people. If you're the kind of person who wants to know what works before you need it, subscribe. Share this with someone who heats their home. Now I'm going to be honest with you about what this can't do. Fire risk is real if you use inadequate clearances or failed insulation. This is the primary code concern. It is legitimate. Hot surfaces present burn risk. You must insulate properly. You must maintain clearances. Structural load matters. A 55-gallon drum filled with sand weighs several hundred kilograms. Your floor structure must support it. Carbon monoxide risk applies only if you're using a combustion-based charging method. Electric and solar thermal charging produce no combustion gases. Energy density is limited. This is supplemental heating or single-room heating. This is not a whole house furnace replacement for a large, poorly insulated home in extreme cold. There is no thermostat. Discharge rate is governed by physics, not a dial. Charging dependency is absolute. You must charge the battery first. This stores energy. It does not create energy. The pechka had these same limitations. Russian families managed them for centuries. You can too, if you understand them. Here's exactly how to build one. Step 1. Container. 55-gallon steel drum. Clean. No chemical contamination. This holds the sand and contains the heat. Step 2. Sand. Silica sand or play sand. Dry. Here's the energy formula. Energy in joules equals mass in kilograms times 830 joules per kilogram, Kelvin times temperature change in degrees Celsius. A 55-gallon drum holds roughly 200 kilograms of sand. Heating that mass from 20 degrees Celsius to 300 degrees Celsius stores 46.4 million joules. That's 12.9 kilowatt hours of thermal energy. Step 3. Heating element. 3 options. Electric. Kiln element or cartridge heater inserted into the sand mass. Solar thermal. Coiled copper tubing running through the sand connected to a solar thermal collector. Wood. Rocket stove with exhaust, routed through a steel pipe embedded in the sand. The pipe transfers combustion heat. The sand stores it. Step 4. Insulation. Ceramic fiber blanket, mineral wool, vermiculite or perlite surrounding the drum. Insulation controls discharge rate. Insulation prevents surface ignition. Insulation prevents burn injuries. Thicker insulation equals slower discharge, equals longer heat duration. Step 5. Heat distribution. Passive radiation. The drum radiates heat into the room. No electricity required. No moving parts. Or active distribution. Small fan directing airflow across the drum surface. Ductwork channeling warm air to adjacent spaces. Step 6. Charging cycle. Heat the sand to your target temperature during grid-up conditions, or during solar gain hours, or during your wood-burning window. Switch off the heat source. The sand discharges passively. Repeat when temperature drops below your comfort threshold. That's the build. Those are the steps. That's the system that codes prohibit and physics validates. Step back and see what you just learned. Russian families survived on thermal mass 700 years ago. They heated stone and brick and slept on the warmth through the night. Swedish engineers refined it into an art form. Ceramic tile stoves with flue path is engineered for maximum heat transfer. Finland commercialized it at industrial scale in 2022. 8 megawatt hours feeding a district heating network. America's own national lab proved it works. NREL validated sand thermal storage with your tax dollars, and the building code says you can't have it. $300 in materials versus $12,000 to $25,000 for a furnace, plus monthly bills that never stop versus zero fuel cost if you charge with solar or waste heat. You now have the knowledge, you have the science, you have the build. Someone you know heats their home with a system that stops working the moment the grid does. Send them this. Next video in the vault covers thermal mass sizing calculations for specific climate zones, regional code variance analysis, and the legal gray areas where this might actually be permitted. This isn't entertainment, this is preservation. The knowledge existed, it was proven, it was built, then it was regulated into invisibility. You just got it back.